In programming, you often hear about noises, and certainly I'm not referring to baby cries or traffic, etc. I'm talking about the patterns that provide us with a sense of randomness. Although noises are not completely random, they still give us a huge variety of possibilities. I'm going to present multiple types of noises in this series, some more complex than others. And by the end of this video, we're going to turn the grid we've created in part 2 into an actual terrain. Well, I've told you this episode will be more exciting than the others, and I don't think I lied. I'm sure all of us are familiar with this type of function. It returns a boolean 1 or 0, same as true or false. The problem is that this function isn't really useful for us, since the rendered version looks terrifying. At least it has no specific pattern, although it is a type of noise, which is called a random noise. This is a Rust code fragment from episode 2. I've modified a bit so that I use x and z notations instead of index 1 and index 2. X and z are commonly used in rendering arrays, since they set the path position x and z. Now the entire point of using noises is to make things more automatic. In a nutshell, we're making the computer design a terrain and render it. We're not designing the terrain anymore, so we can delete the contents of the array. I have here the getRandom function, and I think I will render the array based on colors instead of heights. That makes more sense. Alright, in this fragment we are rendering the 2D array. However, the code doesn't work anymore, as expected. That's straightforward because we deleted the entire 2D array a couple seconds ago. So we need to make the computer fill the array. Setting and getting data from an array works nearly the same way, so we recreate the two for loops and fill the array with random numbers. Also, don't forget a 2D array is just a bunch of 1D arrays. Now, if we press run, we should see a QR code. Clearly, this getRandom function doesn't help us at all. Luckily, someone encountered the same problem in 1983. That someone was Perlin, who wanted to improve the CGI of the movie Tron, so he created the Perlin Noise. Now, in this video I'm not going to explain how it works, since I have barely any idea about this myself, but I will show you what it does and when to use it. I think the most basic use case will be for a sequence of numbers. Take for example 10 numbers generated using a typical random function and 10 numbers generated using the Perlin Noise. Now, rendering those numbers makes our story much more interesting. There is some kind of smooth pattern. There are no sudden changes going on, and as we guessed it, this is the foundation of procedurally generated words. The Perlin Noise is the key to create environments generated by computers. Perlin Noise can also be replicated in 2D. You will find the same pattern with no sudden changes. Perlin Noise output is between -1 and 1. We can convert it to be between 0 and 1, so we can set 0 for black and 1 for white and render a similar image like you're seeing right now on the screen. This is our new noise function. In a nutshell, the greater the terrain smoothness is, the smoother the terrain will be. It is like zooming into the noise. Noise x and noise z must not be integers. That's why I use 10.1 for terrain smoothness instead of just 10. I have no idea where you're going to find a 2D noise function. Engines like Roblox or Unity already provide a similar function, so I wish you good luck to find a working 2D noise function. And I also wish myself good luck to not say function anymore. I clamped the value just to make sure it is between -1 and 1, then converted it to be between 0 and 1. And that's the most basic Perlin Noise you can get. Now, if you want to feel like a boss, you can also try modifying the height and color based on the noise value. That's it for part 3. This might not be the best train generation in the world, but we made huge improvements since the last episode. I said we because I hope you also coded something similar while you followed along. As always, if you have any questions, ask them in the comments down below, and see you next time.